Good morning. We're going to continue talking about probability, and we're going to talk about compound events. So we've been talking about simple events or one-step events, and now we're going to be talking about events that have multi-step actions. In other words, they're going to involve more than one step or choice. So an example would be spinning a spinner twice. That's a two-step action. Choosing 4 people from a group, that is a 4-step action. Or rolling 3 different number cubes, or 3 dice, or 2 dice. That's a 3-step action. So a compound event is an event associated with a multi-step action. So before we just rolled one die, and we were looking at just one roll of that die. And so that was a simple event. So this time we might roll the die twice, or we might have 2 dice. So as soon as we go into more than one thing, that's when we're talking about compound events. So we're going to look at how do we write those, and what are some examples. So a multi-step action, for instance, if I go through the cafeteria and I choose 1 fruit and 1 drink. Well, the number of steps in that action, I've done 2 different things. So there are 2 steps in that action. There are also the possible compound event is that I'm going to choose an apple and milk carton, or carton of milk. And I'm going to write that as apple milk, because I'm choosing a fruit and then I'm choosing a drink, and I'm doing it in that order. In our next example, we're going to spin the spinner twice, and I want to spin a red and then a yellow on the spinner. So that is the probability of red, yellow, and you might see that written like that as well. A red and then a yellow, so I have to put them in that order. If I'm choosing a 6-character password, which is pretty standard, there are 6 different events that are happening. So 6 different actions that are happening there. So the first one, I want to spin, or I want to choose an A. The second, a B. The third, an I. The fourth, I'm going to choose the number 5. For my 5th one, I choose the number 7. And for my 6th one, I choose the number 8. So I have A, B, I, 5, 7, 8. So I need to go in that order. Next one down here, I'm going to roll 3 number cubes. And so I have 3 different events that I'm looking to happen, or 3 different actions rather. So the possible compound event is the blue cube is a 2, the red cube is a 6, and the green cube is a 2. And so I'd be looking at 2, 6, and a 2. So our question down here said, does order matter in compound events? Well, yes, it does. For example, up top there, spinning a red and then a yellow means I need to do it in that order. And maybe in a game that you're playing, that gets you a different space. Then spinning a yellow, and then a red would. So I always think of Candyland. If I picked up or spun a red and then a yellow, that's going to end me somewhere different on those 2 turns than if I do a red and then a yellow, or yellow then a red. So order does matter in those instances. Also with my password, if I don't put these in the right order, it's not going to work. It's not going to go, oh, well, you have all the right letters and numbers. They're just not in the right order. That'll work. We can do that. That's part of what makes your password so protective, is that there's a certain order to it. It can't just be those letters and numbers. They have to be in a certain order. So now we're going to talk about independent events versus dependent events. And in an independent event, one thing does not rely on the other. In other words, if you're working independently, when you finish your work, doesn't affect the person sitting next to you. You are independent of each other. So independent events are a type of compound event where the occurrences of one does not affect the probability of the other event. So, for instance, the action choose one tile at random and then I replace it. And when I replace it, then I end up having the same number of letters that I started with. So my sample space doesn't change. So that is why one event doesn't affect the other. If I pulled that letter and I didn't replace it, then my size of my sample space decreases, and that would affect the event or the probability of that event. So when I replace it, it's independent. Then choose a second tile at random. So compound event is choose A and then choose B. So the probability of choosing tile B before choosing the first tile should be the same as choosing a B, the event of choosing the letter B, after replacing the first tile. And that's how I can tell that they don't affect each other. So if I look at this, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tiles. And there are 2 letter Bs. When I pull a tile and then replace it, I still, like I said, have 11 tiles, and there should still be 2 letter Bs there. So this is the second part of the event, and since the second part of my event, my compound event, doesn't change, that's how I know that it's an independent event. So the probability of choosing A is 1 out of 11, and the probability of choosing B is 2 out of 11. So since that number in the denominator does not change, since it is not affected by the first choice, then the events are indeed independent of one another. One does not affect the other. Now, in dependent events, that is the opposite. So dependent events are compound events where one does affect the other. So for instance, in our same example here, if I don't replace that tile, it says choose one tile at random and set it aside. Do not replace it. That's when we're going to have a dependent event, when I don't replace what I took out, because my number and my denominator is going to change. So before choosing the first tile, there's 11 tiles, and there are 2 letter Bs. Now, after I choose my first tile, if I don't replace it, so after not replacing the first tile, I'm only going to have 10 tiles left. So no matter what tile I picked, say it was the A, I only have 10 tiles left. So then my probability goes down to 2 out of 10. So now I have a greater chance of picking the B. My percentage increases, my percent of my chance of possibility of picking a B increases because there are fewer tiles to pick from. So the second choice is affected by the first choice. And this is a dependent event because one event depends on the other. So let's see if we can figure out which one's which. Are the events that make up each compound event independent or dependent? So the first one says player 1 chooses a game piece and player 2 chooses a game piece. That is the action. That's what's going to happen. So the compound event that player 1 chooses red and player 2 chooses green is a dependent event because once you pick your game piece, you don't put it back. You would keep it. Otherwise, someone else would pick it and you wouldn't have your original game piece, and then you would keep picking. It would just go on and on and on. So this is a dependent event. When I spin a spinner, and the spinner stops on green twice, well, that can happen because when I spin green, I don't take it off the spinner. So this is an independent event. I can spin green, and the next person can spin a green because that spinner isn't going to lose those pieces. We're still going to have the same 4 spaces to land on. So when we have these compound events, we often need to take a look at the sample spaces and what the actual outcomes are, because it isn't just red or just green. There is more than one thing happening. So we can organize our possible outcomes in multi-step actions or compound events using one of 3 models listed below. And the first one is called an organized list. So in this first one, I get to pick 2 scoops of frozen yogurt. I have 3 different flavors. Now it says I can pick the same or different flavors. So if I pick the same flavors, I could do peach and peach, I could do strawberry and strawberry, and I could do banana and banana. Now, I don't know about you, but I like a little variety. So I might look at choosing 2 different flavors. So if I choose 2 different, I could choose peach and then strawberry, or peach and then banana. I could also choose strawberry and then peach and then strawberry and then banana. I could also choose banana and then peach, or banana then peach, or banana or strawberry, in that order. So I can see when I make out my list of my scoops that I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different possible outcomes. Now, if it tells me that I have to choose 2 scoops, scoop 1 and scoop 2 must be different flavors, my possibilities, these 3 are going to go away because my scoops have to be different flavors, which means only these 6 are going to be left. So I can have peach and then strawberry, or peach and then banana. I could have strawberry and then peach, or strawberry and banana, or banana and peach, or banana and strawberry. Using abbreviations of letters is very helpful in these instances. On our next one, you might want to use a geometry model. So it says, on a scavenger hunt, a clue leads you to a locker with a note on it. What are the possible combinations for the lock? It says, open the locker to find your next clue. The combination is a number XY. The digit X is either 7, 8, or 9, and the digit Y is 0 to 4. So these are going to be my X's up here, and these will be my Y's down here. So my X's can be 7, 8, or 9, and my Y's can be 0, 1, 2, 3, and 4. My X's, it says, goes first, so 7 and then a 0, or 7 and then a 1, 7 and then a 2, 7 and then a 3, or 7 and then a 4. Same thing happens if my 8 is first, and also if my 9 is first. So this helps me keep track of these because I end up with 1, 2, 3, 4, 5, 10, 15 possible outcomes. So that geometry model helps me keep it straight. Another common one to use, and one that I think you may have seen before, is called a tree diagram. So I can list the number of ways boys and girls can be born into a family with 3 children. So the first child could be a boy, and the second child then would be a girl. So if I get a boy the first time, I could get a boy the second time, and a boy the third time. I could have 3 boys. I could get a boy, and then a girl. I could get a boy, a girl, and then a boy again. Or I could get a boy, a girl, and then a girl again. So on that first top part, I have boy, 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 girl, boy, girl, boy, and sorry about that, and boy, girl, girl. So those are my top options.